Okay, this is the fifth part of my 2D motion series, and now we're going to look at resolving complex vectors. When I say complex, they're no longer only going to be like this on the x-axis or y-axis. They're going to be two of these vectors that end up being like this, and we're going to have to start off by breaking those into their sides, and then we're going to add these vectors that are on the same axes together, and we're going to come back and then come up with a final triangle at the very end. So this one's a little easier than that one because this one here has two components to each triangle, and let's see how this is done. So the first type of example, Sarah ran 60 meters north of 20 degrees north of east. Let's go and draw the triangle. Follow it backwards. East, north from east, 20 degrees. The resultant is 60 meters. If you're having trouble with this part, go back to a previous lesson. Follow one of my other parts of the series. Okay, and now what we want to do is we want to go ahead and we followed that. Let's go ahead and just draw everything out first. We followed that by a vector that was 100 meters north. And so we're going to be adding these two together. We're going to have to figure out what this one's y component was. And so that angle opens up to the opposite. We have our hypotenuse in our given. And we're going to go ahead and solve for that one. So that will be opposite equals the sine of the angle, and this is 20, times the hypotenuse, which is 60. And so this answer is going to be sine of 20 times 60 equals, this one ends up being 20.5 meters. If you're not getting that, watch your calculator. Make sure you're in degrees and not radians. And so this is our, I'm going to call this triangle 1, and I'm going to call this y1. So this is our y component of triangle 1. And triangle, or not triangle, but just the thing 2, the line 2, has a y component as well. So this would be our y2, and then its x2 would equal 0. So I'm not concerned with the x of this right here. It doesn't have any x-axis component. But we want to find our x1, so we want to find this one, our x component of this triangle, and we want to find the x component is the adjacent. So this time I'm not concerned with the opposite, I'm concerned with the adjacent and the hypotenuse. So I go over here and find the adjacent hypotenuse, and that's cosine angle equals adjacent over hypotenuse. Now when I want to solve for adjacent, break out the hypotenuse. So it ends up being, to figure this out, it's going to be equal to the adjacent side, which is equal to the cosine of the angle, which is 20, multiplied by the hypotenuse, which was 60. And then finally, when we do the math, cosine of 20 times 60 equals 56 point, we'll go ahead and just say 4.38. Once again, I'm not really going for significant figures. These all would have 1, so it'd be a really bland problem. I just made this up. And that will be meters. And so at this point in time, we're just taking, it's just a long, lengthy problem, takes a couple steps. Now we're going to go ahead and we're going to add our y components together. So we're going to get a y total, and that's nothing more than the y1 plus the y2. So y1 was 20.5. It was in the north direction, so we'll call it positive. And y2 was also in the north direction, so we'll call that positive. So we're just pretty much adding those numbers together. 120.5 meters north. And our x, there was only one x component, and this was 56.4 meters, and it was to the east. And now we have a problem just the same as we had before. When we put these two together, we go ahead and we will draw the triangle again. And it doesn't matter which one you do. Once again, you have an alternative correct answer, but we'll go ahead and my first one I see here is 56.4. So 56.4 meters followed by 120 meters. It's not to scale because I ran out of room here. And then we're trying to solve for this and this. So we're going to do to find that, we're going to do Pythagorean theorem. So it's going to be C is equal to the square root of 120.5 squared plus 56.4 squared. And we get C to be equal to 120.5 squared plus 56.4 squared equals, so 17,701 before we take the square root of that answer, and that ends up being 133.04, so 133 and that was meters. And then when we want to find this angle, remember angle is inverse tangent because we have an opposite and we have an adjacent. Here this opens to the opposite, this is the adjacent. So inverse tangent of opposite, which is 120.5, over adjacent, which is 56.4. And we get our angle to be inverse tangent in my calculator, 120.5 divided by 56.4. And I get a degree of an angle of 64.9 degrees. And now our final description, I'm going to go write it over here. These, once again, take a lot of room. My final description is going to be 133 meters, 64.9 degrees, and this one would be to the north of east. That's how you do this problem. And then the last problem, I'll do one more, a little bit more complicated. Once again, the other one that I told you. I'm going to try to write smaller so I can actually fit it into the space. A plane flew 150 meters per second, 35 degrees north of west, and the wind was blowing 30 meters per second, 20 degrees north of east. What's the overall velocity of the plane? So once again, it doesn't have to be displacements. It could be velocities. It could be accelerations. Let's go ahead and draw that first triangle. North of west would be, first of all, go west, and then go north from west, and then throw the angle in there. 35 degrees, 115 meters per second. So this is our first vector, and our second vector was the wind was blowing 30 meters per second in an angle of, or 20 degrees north of east, so go east, that's not east, go ahead and go east first, and then go north from east, draw the resultant line, draw the 20 degrees in there, and put the 30 meters per second right here. So we're going to have, we'll call this 1, we'll call this 2, we're going to have a x1, y1, we're going to have a x2, we're going to have a y2 that we're going to be concerned with, and we're going to have to break them down, and then we'll put them back together and make a new triangle. So let's solve for, the x1 is going to be the adjacent, because the angle is right here. The y1 is going to be the opposite. So x1 equals adjacent, which equals the cosine of 35 degrees times the 115. And that ends up being cosine of 35 equals times 115. Ends up being 94.2 meters per second, and that would be west. And then our y1 is going to be our opposite, and that equals sine of 35 degrees times the 115. And that one's going to be, so sine 35 times 115, that one's going to be 65.96 meters per second, and that one was north. And let's go ahead and break this triangle down. I'm going to go ahead and start doing this one here. This x2 was the, in this case, it's also adjacent because it happened to be on the side. Once again, it's not always going to be that way. You always have to look at the triangle to determine. And so since it is the adjacent, and we have our hypotenuse here, we're going to go ahead and take the adjacent equals cosine of 20 here times the 30. So cosine of 20 equals times 30 equals, and I get 28.19, and that was meters per second, and that was, this one is going, x1's going to the east. So we're going to have a problem here. We're going to have to do something with that. We have east and west going on. We can't just add them together. We're going to have to subtract something. And then we have our y2. Our y2 right here is our opposite, because it's opposite of that 20 degrees. So we're going to go ahead and say opposite equals the sine of 20 times that 30. And when we get that answer, it's going to be sine of 20 equals times 30 equals, and it ends up being 10.26 meters per second, and that one is north. Okay, so now let's go ahead and add our totals. X total is nothing more than this one right here. Now, since these contradict, I'm going to go ahead and say west is negative. So it's going to be, you're going to add negative 94.2 to a positive 28.19. So we're going to combine our x components. So our x total is going to be negative 94.2 plus 28.19 equals, ends up being negative 66.01, but I'm going to go ahead and erase that negative, and I'm going to go ahead and make it what it was in the first place. It was west. So a negative x is going to be a west. So this is one of my vectors. And then I'm going to finish off this y vector. This y vector is going to be, or the y total is going to be, they're both north. That's nice. So they're going to both be positive. I'm never going to need, since it's both directions, they're both the same, we're going to go ahead and just keep positive for both of them. We keep positive for north anyways. So 65.96 plus 10.26 equals, and I get 76.22 meters per second north. Now we want to go, this is finally a nice basic problem. We want to put these two vectors together to get our final answer. So as you can see, I'm running out of room. Let's go ahead, I'll just go ahead and do the first one north. 76.22 meters per second. And then I'll follow that up with 66.01 meters per second west. And now we want to get everything here. So we're going to start off by figuring out our C, our hypotenuse, which is square root of 66.01 squared plus 76.22 squared. And that's going to be 66.01 squared plus 76.22 squared equals, and we take the square root of that answer, and we get, I have in my calculator, it says 100.8, and that's going to be meters per second. And now we want to find the angle, and to get the angle, we have to take the inverse tangent. So angle equals tangent negative 1 of the opposite, which here is going to be 66.01, over the adjacent, which is 76.22. So we get inverse tangent, second tangent. The second tangent on my calculator, your calculator might be different. 66.01 divided by 76.22, close parentheses, hit equals. I get from my answer 40.89, so we'll just say 40.9 degrees. And so my final answer here, so I'm describing this, this is what I'm trying to describe. Final answer here is 100.8 meters per second. There's my magnitude. 40.9 degrees, there's my degrees, my angle, and then I need to describe this, and this is to the west of north. And there you go, that's a nice long problem.